Yeah, a very good morning to one and all. I'm Praveen Kumar. Today we are going to solve a real world challenge, and the challenge is data migration at scale. Suppose you are having a 5 lakhs of records and you need to migrate them to the database. So instead of sending each request within an order, or it will crash out of the memory and you will get something called OOM, out of memory error. So I solved this challenge by using some techniques like Django, ORM, advanced techniques using iterator and bulk create. So I have created and solved this challenge by a solution called ETL pipeline, extract, transfer, and load a data pipeline with custom management commands. So in this project, I'll walk you through how I solved this challenge and with practical demonstration. So yeah, this is my GitHub repository. So the challenge Django ETL pipeline high performance data migration. So in this challenge, I have created a system that can migrate 5,000 of five not 5,000 lakhs legacy order containing nested JSON data into a normalized relational database schema. So I have created a seed data with 5 lakhs of records with a nested JSON. So it is not possible to store a nested JSON inside a relational database. So we need to normalize the data to store in the relational databases like PostgreSQL I have used in this project. So this pipeline focuses on advanced ORM Django's optimization techniques, specifically utilizing server-side cursors. Yeah, iterator is not a normal database sending request to create an order or migrate an order. It uses something called server-side cursors for memory safety and batched insertions called bulk create, an advanced ORM technique in Django for maximum network throughput. I'll show you the practical demonstration also. So it is fully containerized and idempotent and resumable. Uh, idempotency, idempotency means processing a request multiple times cannot give the different details. It should give the same data once it processed. So it is a key skill in designing this type of pipelines. So architecture and technologies, I have Django. You can use Django 4.2 plus and PostgreSQL 15 infrastructure Docker and Docker Compose. So it can be able to run at any system and Python. So you should have your systems downloaded with Docker Compose. So you can just create Docker file and run these commands. So we have to just install your Docker desktop. Okay. So I have created a seed data with this script. It will be creating 5 lakhs of records, and in each batch it is adding 10,000 of records. So yeah, the nested JSON data it will be like items. So without this advanced ORM techniques, I have created a benchmark file. It nearly look 492 MB in memory. I have collected this data by using trace malloc, a function in Python used to trace the how much of memory is allocated inside the RAM. So the optimized approach using iterator, it was nearly decreased to 5 MB. So the space of RAM decreases in the memory in server side. So you can create a Docker file with two services. One is database, the image I have using Postgres 15, and the app that will be building from our source code. So as you know already everything. Coming to our main core structure of our project. This is our heart of our project because everything will be run from here. So the main things like custom management commands. You can create your custom commands using inheriting from base command. So when you write when you run something like python manage.py and your custom command, it will hit this method. So we are using batch size and dry run. So I have used query set and filtered whether the data is migrated or not. So we just want to migrate the data that is not sent to the database. So as you know, query set will be used to cache the data from the taken from the database. So this is the normalized schema. What we are taking from the nested JSON is converted into a normalized schema. So perf counter is a method in Python used for performance counting. So we have just created at start time and end time to calculate how much of time is required, and the total time will be end time and start time. The throughput, how many records are processed by the total time. So you can use std.write because it will be supporting something like in green color if it is succeeded, if it is get error, it will be in the red color. So this entire logic will be written in the atomic transaction. Not atomic means if anyone is succeeded, the whole thing will be succeeded on the database. If something broken while executing, the it has to be revert. I mean, it need to execute from the start. So I have used something called bulk create. So the coming to the practical, let us check where Docker was running or not. Yeah, it was running. Okay, let's start the. So yeah, the containers were started. You can check the status of the containers. Both are in running state. Okay, let's create. Let's apply the database migrate. So yeah, nothing to apply on my side. If you are something new, you can apply. If you are making any changes, okay, let's seed the data into database. So if you are not using something like advanced ORM techniques, uh, we'll be getting something called OOM errors, out of memory errors. So Django has to create a network connection for each request to process. So it will be taking nearly 5 lakhs of requests for inserting. So we are making something called batch sizes. You can see that. Yeah, batch for each batch we are inserting 10,000 of records. So the total records will be 5 lakhs. So in that way, it has to be. Let's get into running the ETL pipeline. So yeah, we are just running the pipeline with a batch size of 1,000. Yeah, it's been inserting. Yeah, total 5 lakhs of records has been inserted. So what we are doing is taking these orders from the database again. This is called transform phase. Once we have extracted and transformed to the normalized schema from just nested JSONs to normalized schema. Yeah, for each iteration, no, not iteration, for each step, it has been processing 1,000 records. So how dry run mode will be helpful to test the pipeline logic and calculate expected processing volume without committing any changes to the database. So dry run will be helpful to how much of time has been consumed for each thing. So okay, meanwhile I'll show you the benchmark file, how I benchmarked the solution. So in each batch, for example, with the batch size of 100, that migration took time for nearly 113 seconds, and the network throughput nearly 4386.43. So have you observed one thing? So the batch size of 1000 provides the optimal balance, maximizing our throughput to over 8700 records per second. For if we are just using dot create, the loop it queries nearly about 3000 queries. So the optimized version uses only bulk create 4 queries. Okay, let's see whether the yeah, completed. So the network throughput nearly about 4687. Okay, let's create a dry run. So yeah, I forgot to tell you one thing. Just we have migrated all the data, so there will be nothing records in the database which are set it to migrated equal to false. So that's why we are getting throughput as 0 records per second. So that's it, guys. How I solved this problem using ETL extract transfer and load to handle 5 lakhs of records in production grade applications. That's it. Thank you.